Hello again, and we are going to do a belated laser video. This is one that was inspired earlier today by a user, Dorian Barrett, who posted, "Love the video. I upgraded my Meturk as instructed in the video. However, my laser has no power. Help." And as I was writing a reply, and I posted the reply, I realized I could probably just do a video on the troubleshooting techniques for checking to make sure the laser is connected properly, just as well as I could type it. So this is going to be a little video about the troubleshooting steps of how to troubleshoot the laser and the laser connections in your laser machine. So the first step I mentioned in the video was to make sure that the laser module itself was good. Now, I am assuming that Dorian is using the stock laser module that came with his, the same as this, roughly a 5-volt laser. And the first step in this test is to make sure that this laser module itself is working and good. And the way we do that is, you don't have to pull it out of the machine, but I did just for the ease of work, because you take these 2 screws out. It's not hard. But is to take the laser module out and connect it up to power directly with these 2 leads and see if the laser turns on. And then you know that the laser is functioning properly if it comes on. So how we do that is, from the other videos, you might remember this power supply that I use, which is a power supply, has a computer plug on one end and one of these computer drive plugs on the other. And these kind of power supplies provide us 12 volts and 5 volts, so they're really convenient for working with these laser systems, because we need 12 volts for the motors, but 5 volts for the laser. So we have 12 and we have 5. And then I have this pigtail that I've made, and it's the design is outlined in previous videos. And in a very, very completely safe, and note the sarcasm, way, I have got these alligator or crocodile clips, depending on what you prefer, connected up. So the green wires connected to this black wire are the negative or the ground from this box. So I have it going from the ground pin through here to this ground crocodile pin, and then to my laser module, and it's going to clip to the black wire. Boom. And note that the power is not plugged into the power supply. This is for safety. I'm going to take this other lead, and it is connected to, in this case, it's a red wire, but consult the markings on your power supply to make sure you don't connect it inadvertently to 12 volts instead of 5 volts. But this wire on mine is going to 5 volts. And so I have done my crocodile clip to the red wire there, and it will go to the red wire on our laser. Let's push the little covers up so we don't get a short. Now, everything is connected. We have, in theory, the power going to this, but it's not plugged in yet because, haha, safety first. So these are the cheap glasses that came with the laser, and of course they're better than nothing. They're probably not great, but they're better than nothing, so make sure you put them on. I'm going to put mine on, and then we are going to aim the laser in a safe direction and apply the power. And can you see? Yep, the video is, you can see that dot, and I'm not going to get it too close because I don't want to, burn anything, but you can see that obviously there's a dot, so the laser itself is functioning properly. And let's quickly unplug that. Okay. Now, unplugged, it's safe. Cheap glasses that don't do anything, probably. Actually, they do something, but anyway, cheap glasses off. Okay, so that is the first step. So we know the laser diode is working and functioning properly. So the next step is to check all of the electronics in the laser, in the engraver itself on the GRBL board, and we're going to do that in the next step. Now here we are for the next step of troubleshooting, and we're going to figure out if we have the laser connected up properly to the pins. For this step, you can see I'm looking at the back of the unit. Here is the Arduino Uno, and then the GRBL control board that we installed in the other video from so long ago. And important note for this video, the power supply will not be plugged in. We will not be using external power for this. It will be using only the power provided by the computer when we plug it into USB. One of the things I think is happening with some people who are having trouble with the laser pins not working is they may have it connected to the wrong pins inadvertently. Now, what I think happens is that depending on the kind of board you have, the pins might be different slightly than what they are labeled. If you have a board that's designed for GRBL 0.9, as most of these cheap ones are, and mine is as well, there are two pins. There's spindle enable, which you would expect to plug your laser into. And when you install GRBL 1.1 onto this board, it installs fine. But if you then enable PWM, the pulse width modulation, to vary the laser brightness, GRBL will switch the spindle enable pin with the end stop ZZ end stop connector up here. And the reason it does that is boring, but the short is that when this board was originally designed, the pin that the spindle enable was connected to could not send the PWM signals. It was physically unable to do that. So when the versions of this board that came out when GRBL 1.1 came out, which supported PWM, they had to switch it with another pin, which was this Z-stop pin. And so this board was designed with GRBL 0.9 in mind, but I have 1.1 installed, and I have PWM enabled. And so let's get close to the pin connectors here. Now we can see this is the spindle enable pin block here. You have the signal pin here, and then you have the ground pin for it there. Now, under GRBL 0.9, this would turn the laser on and off. But if you have GRBL 1.1 installed and you have PWM enabled, the spindle enable pins get swapped for this pin up at the very top. It says Z+. So with the PWM stuff under 1.1, this becomes the laser control pins, and these will become the end stop pins if we had end stops installed in this, which we don't, so we could ignore it. So that, I think, is one of the biggest things that is hitting people, is they probably rationally plug the laser in here because it's labeled like that. It makes sense. But in this case, because the board is a little bit different, it actually needs to plug in here. So let's plug something into these, and then I'll show you a good way to test to make sure that it's actually plugged in properly. An easy way to test if the pins are set up properly and working is we don't need the laser. What we're going to do is we're going to connect an ordinary red LED to the signal pin and see if this lights up. And if it does light up, we know that we've connected it properly. And if it doesn't, we know there's something wrong with our configuration or something physically wrong with the pin. And so we do that. I've got a length of this jumper wire, and it has these female connectors on one or both ends. You really only need them on one. And plug them in. One connector on the ground side, and I like to keep them the same color. So we have black is ground and white is signal, and it's going to the one at the top that says Z+. And then for our LED connection, hang on, I need to put some male wires here to go into that little breadboard. Now, mind you, if you didn't have a breadboard, you didn't want to, you could solder some wires together and get close to the same thing and just touch them and have it work, but I have breadboards lying around, so it's easier. So we're now going to connect the ground. Let's get this into frame so you can see. So we're going to put the ground there and the signal here. And the resistor is here because this will be sending 5 volts. And this LED is only rated at 3-point-something volts, so it could potentially burn this LED out. So the resistor here is to protect the LED from burning out. So we've got this white wire going here, which is going to be sending electrical power. It's going to go through this resistor, light up the LED, and then go back to the ground. And this is going to like pretend to be what the laser would be. So let's set this to the side here, and let's plug in. I guess get it in shot so we can see better. So plug in the USB. This whole setup will be powered by the USB from the computer. So we don't need the main power supply, don't need the laser at all. And on my main computer, I am going to connect up and issue the command to turn on the signal on the pin. And in the case of GRBL, that would be M3. So M3 space S255. So S255 means the power that it's going to be turned on as. 255 is the maximum in this case. And if I press enter, There, we see the LED lit. And then to turn off the signal, you do M5 with no arguments, and then whatever. Now, if you don't want to remember M3, M5, just in whatever program you're using for doing your GRBL slicing, just tell it to turn the spindle or the motor on and turn it off. The interesting thing, too, which will illustrate what we're talking about with PWM, is I'm going to turn on this LED to a, let's turn on, first of all, this is going to be full brightness. Hang on, M3. Okay, you can see how bright that is. Now I'm going to turn it down to half brightness. It's hard to see on camera, but it did dim a little bit. And let's get it down to a quarter brightness. There, now you can see it really dims. And get it all the way down to about 5% brightness. You can see it's barely visible there, but it is. And then M5 turns it off. Boom. So this proves that the pin is functioning properly and that it's getting voltage. Now, let's say you had inadvertently, you had either a GRBL 0.9 installed, or you had 1.1 installed, but PWM was not enabled. Then you would move both of these plugs down here to spindle enable and plug that in, and then issue the same command and see if that would turn on the light. Then you'd know what pin set is configured for what. But this one, you can see very faintly there with the LED. Watch as I unplug this. See, it goes off and then on. So there's a very small voltage being sent through those pins because they're end stop pins. And when we add end stops to this in a little while, we'll cover what those are. But it's sending a little voltage across those pins all the time. So if you plug it in, you get just this faint glow that you can't control, but you can barely see it. That's also a sign that it's an end stop pin and not the proper signal pin. Now, the final thing to test is chances are using a MOSFET, either you built one yourself or using a pre-built module. This is the pre-built MOSFET module I am using. We'll check to see that the MOSFET is working properly, that it is the right kind of MOSFET, and that it's wired up properly. And again, we do this without the main power connected. We're going to do this purely on the USB power, so there's no risk of you blinding yourself with a laser. So if you have a module that looks like this, then these two little wires are connected to the voltage in and the ground pin. So this is going to be the power coming in as though we're coming in to feed the laser. And then we need to connect some pins here. So let's get things moved around a little bit so we could see. All right, this will work. Okay, we've still got our old LED connected up there, so we're going to borrow some wires from that. Now, we still got this plugged into the Z Plus connection, which on our board now we know is the signal output. And there's a label on this board that says SIG. Now, if you built one of these yourself, this pin is going to the gate pin on the module, which I believe is it's the farthest outside one, but check the data sheet about that. So we're going to connect it to where it says signal. And of course, we're going to connect this one to where it says ground because we need a ground. Oh, that was not ground, that was voltage. Okay. Now this module needs its own power source to run. And so we are going to find another power source to connect up to that. Where did I put my power source? I had one. Oh, is it right here? Nope. Lost my power source. Lost my wire. Here we go. Haha. So this needs 5 volts as well. And we can get 5 volts from this board. You can see in various places. Let's get really close here. You can see right in this yellow jumper block center of the screen, you can see 3V3, 5V. That means that the 5V is going to be sending 5 volts, and we've got the GND blue next to it. So we're going to connect a power wire to this 5V1 so we can get power signal to our MOSFET board. And we'll need another ground for this. So we're going to also connect up to the ground next to it with this other wire setup. Okay, and we're going to put the 5 volt wire, which is the red one, right here into the VCC. And now finally we need to connect up our LED to the V plus and V terminals, which are the output of the MOSFET. And we're going to do that by taking the board we had before and simply jamming these wires into these connector blocks. So we're going to put the black into the V negative and tighten this up. And we're going to put the other one into the V plus and tighten it up. Make sure they're good and tight. Okay. And the final one, you can see that we have the V in and the V out here. We need to get another 5 volts and ground from here. And so we are going to, let's make sure, okay, so purple is 5 volts. We have a lot of 5 volt connectors on these boards. So we have that one, and then way over here on the other side, let's get it into frame, there we go. You can see right here at the very bottom, right next to my finger, it says 5V and ground right below A step. So that means right next to it over here, that will be another 5 volt and ground supply connector. So I will connect the 5 volt. In this case, I did not follow the color coding because I ran out of colored wires. So 5 volt and ground. And I've even kept the power of the USB connected in, so probably was a dumb thing to do, but I did anyway. So now the signal is going to still come out of this signal pin, but it's going to go through our MOSFET, which is then going to control the voltage to make the LED light up. And again, assuming we've done everything properly, on this module, we should have a VCC LED here, which is just cosmetic, but then this light should also light up. So let's try it again. We're going to do M3, S255, enter. Okay. You can see we have an LED on here, and then we have this. In fact, this LED here is going to be doing the same thing that, watch, when I dim this down, you'll see both these LEDs dim at the same rate. See? So this LED is essentially doing the same thing as that. So if you have one of these boards, you can do this test without having to have this external LED, but I did it just, you know, for completeness sake. So this proves here that also our MOSFET is working properly. Let's turn this off. Now the final thing about the MOSFETs, in some other videos where we talked about the wiring for this, I mentioned that I bought this board and it had a different kind of a MOSFET in it, and I replaced it. And this is a really, that's a really good shot. You can see the number. This is, I replaced the MOSFET because we have a thing in electronics called the gate voltage, which means the voltage that the GRBL board needs to send to this MOSFET to turn it on. This is like a switch or like a valve where it can be partially on, partially off. But this MOSFET is designed to work when the electrical levels from the Arduino or from whatever are 5 volts. The one that was here and that I removed was designed to work at levels that were 10 volts. And this board does not send 10 volts to that control system to turn it on and off. And so while it would kind of work, it would only turn it on partially. You can think of it like a water valve, but only opening it a little bit. So it wouldn't really turn the laser on fully. So I swapped it out with this one, which is, again, let's get that really good shot so you can see IRL 520. So in this one, the L in IRL means a logic level, which means it's going to be operating at around 5 volts, which is good to know. And so if you can get a board that has an IRL or something like that, or read the data sheet for these on the internet, you can find them, and look for something called RDS on. It'll be R, uppercase R, lowercase ds, and then on in parentheses right after that, and it'll give a voltage. And the RDS on should be around 5 volts. And if it's around 5 volts, you're good to go. And if it's not, try to find one that operates lower than that. And so this has been the basic troubleshooting steps. So I hope this is helpful to everybody who is trying to follow along with my examples here. And there will be another video coming up very shortly, a couple of them, in fact, where I am finally putting a bigger, different laser in this module, in this laser engraver, and also some advanced safety stuff that we're going to be working on. So hopefully this will tide you over for, I'm hoping, the next couple of days until the new video comes up. And when it comes back, you'll be able to see, there's the proof of the pudding right there. You can see that is not the stock laser. So this is what we have to look forward to next video. So I'll be showing you how to put that thing in and get it working. So until then, I hope this is helpful, and I'll see you next time.